Welcome to everyone online. My name is David Formisano. I'm the Director of Strategy for the Internet of Things group here at Intel. Last speaker for today at day one, and it's really exciting to be here. I'm going to jump into what I want to talk about, which is, of course, the Internet of Things. We're on the cusp of an immense opportunity, and what I want to talk to you about today is about how that opportunity and accelerate real deployments in IoT. We'll look at some of the barriers to what is stopping those deployments. We're going to look at how IoT evolves over time. And so those are the three main elements of my talk, and I'm really excited to be here. So, accelerating solutions in the rapidly solutions deployment in the rapidly evolving world of IoT. If you're at this conference, you know what's at stake here with the IoT. From saving lives to improving efficiencies, lowering costs, there are tons of great use cases that are really going to impact every facet of everyday life, from the way we work, the way we live, across every vertical industry, across the globe. And so that's what's really exciting about the promise of IoT. However, I want to get excited about it, and I want to show you how excited I am about it. So I got a video to kind of show you what this future could look like. So this is the reason, this future that could be upon us is the reason why I'm excited about my job, why I love coming to work every day. But that being said, I do talk to people and I hear from people and they say, will this promise of IoT truly come to fruition? Are we really going to see the benefits? And how long is it going to take for all this to come true? And so when looking at the future, it's often sometimes helpful to look at the past. And so I wanted to take a look backwards before we look forward. And 2017's been a big year, and Apple launched the iPhone 10 to commemorate 10 years of the iPhone. And so 2007, 10 years ago, was when the iPhone and the smartphone era sort of dawned upon the world here. What's interesting is I looked back at what was life like in 2007 as a way of kind of thinking about what the future is going to hold. And the best-selling phone in 2007 was the hot pink Motorola Razr flip phone, if that brings you back. Of course, the iPhone was announced and ultimately launched at the end of that year, but the smartphone era had just started. Now today, 10 years later, 2.4 billion smartphone users on the planet. A huge change. In 2007, we had iTunes, but the Apple iStore hadn't yet fully opened. That didn't come about until 2008. And Android as a platform and as an app store also didn't become available until 2008. So, what we know every day about using apps, it wasn't even possible in 2007. And so 30,000 new apps are loaded or submitted to the Apple iTunes Store every month nowadays. And this is because of the innovation of over 12 million mobile app developers. And so it's this innovation that has brought forth just a tremendous amount of change in the last 10 years. One more view of what that change looks like is today we consume and know about our news and what's happening in the world through Twitter. And yet, while Twitter was introduced in 2006, in 2007 it started to get some momentum. And by the end of 2007, we were seeing about 5,000 tweets per day. Contrast that with today, we're seeing 6,000 tweets per second. So what took a full day in 2007 now takes only a second, with 500 million or more messages and tweets per day. 500 million, I should say, tweets per day. So tremendous and stunning change in 10 years. And really, the fulcrum of all of this, in my mind, has been that 12 million developers building out mobile applications and innovating. And so when I look back, then we start to look forward at the IoT ecosystem, and can we draw some parallels between the mobile ecosystem and the IoT ecosystem? So let's take a look at IoT developers. A couple of other interesting statistics here. 70% of Global 2000 CEOs are centering their corporate strategies around digital transformation. Probably the most famous being GE, talking about transforming to a digital company for a better part of the last 5 years or so. And 62% of developers say that IoT is a very important aspect to the digital strategy. So IoT playing a big role in transforming companies around the globe. But developers are also saying, especially for industrial IoT apps, that security is a top challenge, and that's going to be one of my key points that we talk about today. And then finally, I talked about the number of mobile developers. Vision Mobile, when I started covering the IoT, published a report in 2014 stating that they predicted 4.5 million IoT developers by 2020. In 2016, they revised that number to 10 million because we'd already eclipsed the 4.5 million developers. So 12.5 million developers in mobile today. We're on a ramp toward 10 million developers in IoT. And so we think about what was possible in the mobile ecosystem and what came to light and how radically different our life is today in 2017 than 2007. And I really think that what we saw in that futuristic video and those use cases will be able to come true, but it's with the developer ecosystem. And that's where I want to talk about some of the challenges, because I talk to developers, I talk to customers, I talk to software providers. When I go around the world and talk to them, I hear about a lot of different challenges they're having. And so it's really important as a community we address those challenges. And these are the challenges that are going to be the heart and soul of what I talk about today. So the first one I wanted to highlight, it was mentioned before, is security and privacy. It's a key challenge to deploying IoT. So I want to talk a little bit about Intel's security portfolio and a couple of different layers of security and how we think about it. But as you're going about your world of developing IoT solutions, I think these three elements of security apply much more broadly than Intel's portfolio. And so I think they apply across the board. But I'll start at the bottom, and the first one is designing security in from the start and making it a foundation. Intel is building a set of capabilities, a consistent set of capabilities that we're putting into all of our platforms moving forward, from Atom to Core to Xeon and beyond. And these core elements are around things like protected data in keys, the ability to do crypto acceleration. Platform integrity is a very important part of this, so that knowing that the platform is booted in a secure boot or brought up in a way that is secure. One that I'm going to talk a lot about and is very important to the IoT is identity. We need to be able to identify devices and know that we can trust their identity and be able to start sharing data with those devices. The final thing is trusted execution environment and having space within the silicon where trusted executions can happen. And all of this needs to be exposed to developers like yourself through a set of APIs, through software development kits, and in the integrated development environments. And so this is an important part of our strategy, and as you're developing IoT solutions, it should be part of what you're thinking about when you're developing that solution. Are these things available? But point products don't make an IoT solution. In fact, they're complex. You need to have things at the edge in the network to the cloud. And so building in hardware-protected, secure comms-ready solutions that target certain vertical use cases, whether that's predictive maintenance or fleet management. We're going to talk in a different section about market-ready solutions, but it takes more than the silicon. And it requires understanding the system architecture, understanding the threat models, and building in security across that interconnected set of systems with software. And the third layer of this is around life cycle. Security is not a point in time. In fact, when you bring a new device up and onto a system, that's time zero. But over time, there's new threats, and you have to bring new devices in, take old devices out of service. And so you need to be able to manage security from the creation of a device through the supply chain to onboarding and being deployed. And actually, as I've talked to customers, this is one of the harder parts of IoT. With thousands of devices in a particular deployment, and across all deployments, billions of devices being forecasted to be deployed, onboarding these devices securely and understanding their identity is really challenging. You think about a smart city manager who's in charge of looking out across their fleet of smart streetlights. How do you securely onboard 10,000 IoT light bulbs? In fact, the physical labor to install and then manage these devices through the installation process is actually pretty considerable, because most IoT devices are headless in that they don't have a display or a keyboard. So you generally have to connect another device to them, make sure they're provisioned, make sure they have the right software, and then get them connected to a connectivity solution, and ultimately get the right software, firmware, and security software onto that. And that takes a lot of time and effort. And so Intel has created this capability that we recently launched called the Secure Device Onboard. I'd like to play another video just to show you a little bit about how that works.
The challenge of onboarding and securing the anticipated avalanche of connected things is stalling the move to smart industry and business. Introducing Intel Secure Device Onboard, delivering a zero-touch onboarding model that onboards IoT devices in seconds. Intel Secure Device Onboard uses Intel Enhanced Privacy ID, an IoT identity built into the hardware's trusted execution environment. It offers an immutable identity for the device's hardware that is remotely verified by IoT platforms, while keeping the device's data anonymous and private. The Intel Secure Device Onboard service leverages Intel Enhanced Privacy ID to establish trust from silicon to platform. With Intel Secure Device Onboard, devices can be registered and authenticated to the platform and automatically configured on the fly. Intel Enhanced Privacy ID opens a private authentication channel between the device and the customer's IoT platform for onboarding with Intel Secure Device Onboard. Using the secure channel, the platform can securely update the device image so it's ready to send data. Intel Secure Device Onboard with Intel Enhanced Privacy ID disconnects security from the installer. No human interaction or intervention is required once physical installation is complete, and the solution provides a chain of trust from the silicon provider to distribution to installation on the corporate network and IoT platforms. It's all automatic and completes in seconds. Zero touch, zero worries. Device manufacturers don't need to know where a device will ultimately be deployed, what cloud it will connect to, or how the device is going to be used. Intel Secure Device Onboard vastly accelerates trusted onboarding of IoT devices from minutes to seconds with the zero-touch automated process enabled by Intel Enhanced Privacy ID hardware-based security.
That's a little bit about the Intel Secure Device Onboarding, but it's not just about Intel chips. In fact, we have an ecosystem of providers that allow for this EPID or Enhanced Privacy ID to be used with third-party chips. And in fact, EPID is actually an ISO standard and is something that we're working with a broad range of companies to enable non-Intel chips to be able to take advantage of this security and privacy capability. And on the other end of the spectrum, we're working with IoT platform providers like Amazon Web Services and Microsoft so that they can integrate Intel Secure Device Onboarding and make it an option for their developers. So this is an exciting way of taking elements of the silicon, elements of the ecosystem, and being able to onboard devices securely and in a way that has zero-touch provisioning so that less human interaction is required and less manual labor is required. So the next barrier I wanted to talk about is this community that I'm talking to right now, which is the developer community. And when I talk to customers and software developers, um, there's so many different use cases and so many different capabilities required to deploy IoT solutions, from sensors to kits to software tools. It's sometimes overwhelming. And so some of the feedback I get is, where can I go to get more resources around what I want to go do and deploy? And so I wanted to highlight some of the things that Intel's developing around this space, but also talk a little bit more. It's almost unfair to just talk about developers as one bucket. You know, I think in the mobile ecosystem that might have been more true, but as we look at the IoT, there's a broad range of developers. We have application developers, data scientists, control engineers, a whole host of different personas. And so Intel's working with the ecosystem to try to tailor certain capabilities and tools to different parts of the developer community. We'll just talk a little bit about our developer outreach, and I know that later in the session there's a number of sessions where we'll go into a lot more detail about some of these tools and kits, but obviously getting started, you want to get to developing and prototyping your great idea right away, and so different kinds of development kits can help you do that. And Intel has a host and a range of different kits that have different capabilities in terms of processing, in terms of connectivity, in terms of sensor integration. I'm just showing one of them here, which is our Up-Squared Grove development kit, which includes certain kinds of sensors and a board and power supply so that you can get up and running. In terms of then taking the next step to an IDE, we've got two different options here, and we're really excited about some work we've been doing with Arduino and the Arduino Create capability for rapid prototyping. It's a simple, streamlined capability to interface with these development kits and start prototyping your ideas. But complementing that, we have our Intel System Studio that can really help you move to production and really tune and performance optimize your solution. And we bridge these two solutions so the work you do in Arduino Create is portable into the System Studio. And then finally, we've got a bunch of web resources in terms of sample code, reference implementation, libraries that contain capabilities to hook into a bunch of different systems, APIs and SDKs. And I'm going to talk a lot more about artificial intelligence and computer vision. So we have specialized SDKs that can help you with certain kinds of use cases as well. And of course, Intel works with an ecosystem. And so the Intel Solutions Alliance is a network of providers of hardware, software, solution integrators that can be a great resource for developers who are looking to develop solutions for the IoT as well. I also wanted to highlight a little bit about cellular connectivity, because some use cases require something that's in motion or a diverse set of deployments that range across the spectrum. So LTE connectivity comes in very handy. And one thing that I'm really excited about, we recently announced, is the Intel LTE Quick Deployment Program. And one of the first products to come out of that program is from a company called Sonam. And this device, which is about the size of a mobile phone, includes integrated compute and LTE connectivity, and has the ability to integrate a whole host of sensors. But the amazing thing about it is it's pre-certified on AT&T's LTE network, which allows you to integrate it into your solution quickly and be pre-certified and ready to go on AT&T's network, saving developers the time and effort to certify a device. And that process can be lengthy and costly. And so this provides a great way of getting going right away on an LTE network. And this product is going to be available later in November from AT&T's IoT Marketplace. So a couple of different things I just wanted to highlight there for developer resources. Another challenge that we're seeing is navigating the world of artificial intelligence. When I started working in the IoT group, when it was formed in late 2014 here at Intel, and started talking to customers, a lot of it was pretty simple. Hey, I want to get some sensor data, and I just want to bring it to the cloud. I've got a couple of rules that I want to apply to it, and if I see out of band or I see certain conditions, I'm going to take action. But the world's matured a lot in the last several years. And customers in every segment are looking at, how do I apply neural networks, deep learning, and machine learning to be able to create models based on the data and have those models infer from the data the actions that need to be taken. And so navigating the artificial landscape can be tricky. So I wanted to highlight some of the things that you need to consider as you navigate this landscape. Clearly at the hardware layer, which is where Intel specializes, there's a whole range of hardware options, and Intel's looking to provide a best-in-breed set of hardware capabilities from processors to accelerators to memory to storage. And so this is the foundation of our overall strategy. But anyone who's spent time in the artificial intelligence space knows that the hardware itself, while an important part, it really needs to be connected to a set of software and capabilities. And so Intel is doing the next layer of software above the hardware in terms of libraries, like the Data Analytics Acceleration Library, the DAL layer, the Math Kernel Library, and integrating these capabilities and exposing other capabilities through our Nirvana Graph solution. And so what you're seeing is Nirvana Graph is a Python library for implementing programs that can convert descriptions of neural networks into programs that run across that distributed and heterogeneous hardware layer. Of course, these libraries then plug into the frameworks, and we're supporting all the most popular machine learning and deep learning frameworks, in addition to creating a framework around Neon, which allows for some really optimized implementations for data science problems like image recognition, speech recognition, natural language processing. And those, of course, are connected up into the platform layer and exposed with capabilities like Nirvana's Deep Learning Studio. And I mentioned before that in the IoT, video is becoming a really important sensor. And so computer vision and applying machine learning and deep learning to vision through specialized algorithms is an important way of looking at things, whether you're looking at retail, industrial, smart cities. And so our computer vision SDK is another tool that takes advantage of the underlying hardware and software. So from top to bottom, Intel's trying to enable developers to build out these new experiences using artificial intelligence. So from security and privacy to developer resources and the ecosystem supporting that to navigating the world of artificial intelligence, these are some of the things that I hear about when I talk to customers and developers. But in the end, what really matters is being able to deploy business value. And some of the barriers to doing that, when I talk to end users who are nervous about implementing IoT, they're wondering, how fast can I move to time to revenue? And how hardened are these offerings? Is there an ecosystem there to support it? How do I navigate this complex and fragmented landscape? I used to work with one supplier, but now I have to work with multiple suppliers. And so I wanted to highlight some of the things that are being done in this space. So obviously the business value for end users centers in them getting a business result from looking at the data, and whether that's looking at condition-based monitoring or optimizing their fleet of trucks or fleet of assets. But the opportunity for you and us as developers is around the data analytics services revenue, around creating platforms and software platforms that scale, from professional services revenue to create custom applications that can solve these problems. And we talked about security as being a key component of that. So the overall opportunity to the developer community is large, exceeding $100 billion by 2020. And some of the selected top use cases here are shown on the right. Things like fleet management, video surveillance as a key use case, and video being applied across multiple verticals, like I mentioned before. Condition-based monitoring and understanding what's happening with different assets, as well as things like commercial building automation and breaking the islands of technology that currently exists between heating and cooling, fire suppression, and security and authentication and access systems. So all of these are really great use cases, and as developers are ones that you should have in your sites. And so then if I look at some of the ones that Intel's been working on, and there's a big overlap here, not surprisingly, What we've decided to do as we talk to customers is build out what's called market-ready solutions. These are validated, authenticated, and hardened solutions that we work with a set of partners to deploy into the marketplace. A great example of one that we've been working on for some time and launched this year was around environmental monitoring with Bosch. So smart cities are struggling with keeping up with regulations around air quality, and citizens who live in communities that have air quality problems are concerned about the health of their families. And so by deploying an environmental solution with Bosch into smart cities, we've been able to take sensor technology, security capabilities, data capabilities, and connectivity capabilities, integrate them together and deploy an environmental monitoring solution that really creates new capabilities for smart city managers. Another example is cold chain management. Food that needs to go from point A to point B and kept at a certain temperature. We worked with Dell and a company called IMS to optimize the entire supply chain around items that need to be kept in transit and managed at a cold temperature. These are just a snippet. We've got 30 and growing. And so as you engage with Intel, as you engage with the ecosystem, I invite you to come up with the next set of market-ready solutions. If I highlight one of them and just taking this to the next level, it's good to have a market-ready solution, but what customers are looking for is experience that these solutions actually made a business difference. And so here's an example of one of them around predictive maintenance. I think it's one of the more popular use cases in the IoT. And this is around taking capabilities at the edge where sensor data is created, specifically in some industrial applications, and working with companies like AD-Link and IBM to then predict failures and be able to then change the maintenance schedules so that maintenance is done at the right time and the right kind of maintenance is done at that right time, saving companies cost in terms of labor, in terms of spare parts, and in terms of downtime. And you can see on this slide some of the results that we've been able to gain by deploying these kinds of solutions. So there's a lot of different use cases, integrating them together with an ecosystem, working with partners to be able to make sure they can be deployed, and then working with customers to look at the kinds of implementations and results that we get out of those. The real business value are things that help accelerate the IoT. As promised, I talked about the challenges of IoT, security and privacy, developer and ecosystem, artificial intelligence, deploying hardened solutions. And it's all complicated even further by the fact that IoT continues to evolve. And so it's not a standing still target. In fact, it's a moving target. And so I wanted to spend a few minutes talking about the evolution of IoT and how this may play out. We sort of have a model of 3 phases of IoT. And they're not rigid in that you go from phase 1 to phase 2 to phase 3 in this progression. In fact, some customers are tackling multiple phases at one time. Some are moving through a phase and find that phase is all that they needed to do. But oftentimes when I talk to companies, they're actually moving through the entire arc of this. And the first phase is connected and connecting unconnected device. There's still a tremendous number of assets out there that are unconnected. And value could be created by connecting to them, understanding the data around them, and deploying use cases like the ones we just talked about. And so getting devices connected is the first phase of IoT. If they're not connected, they can't be part of the IoT. And that's why things like Liquid and that LTE quick deployment kit enable people to get devices connected more quickly. But just connecting devices isn't enough. In fact, once devices are connected, what we see is a thirst for things to become smarter. With that data becomes a desire to connect data from point A to point B. This is connecting the energy grid to the vending machine, connecting the weather station to the factory production, and being able to mash up data sources and making much smarter systems. And the first wave of smart systems tend to rely on analytics and sometimes advanced analytics, but oftentimes are rules-based. What we're seeing at the edge, the end of the smart era, is where people start to use and break away from rules engines and into more of an AI type deployment, where big data trains models. Those models are then deployed at the edge, or deployed into systems, and inferencing takes place and is able to take advantage of the data, and the machines can learn for themselves in a way that sometimes humans can't do. And that's what really unleashes the third phase of IoT, which is around autonomous. And so you move from connected to smart to autonomous. And obviously the best example of autonomous is autonomous driving and autonomous cars. And the progression we're seeing in automotive is exciting. But we're seeing autonomy across the board, whether that's in manufacturing, whether that's in retail, where you're starting to see more and more levels of automation, spanning from inventory analysis using robotics to attendantless stores and convenience stores in China becoming very, very popular. And autonomous can also mean the machines themselves become more self-healing in the future and self-configuring. And so we see a world where more and more autonomy takes place, and that's built on the back of artificial intelligence. The other element we see around the evolution of IoT is this coming flood of data. I mentioned automotive. An autonomous automobile generates 4 terabytes of data a day. As we move through these phases of IoT, the devices are creating tremendous amounts of data, much more data than the average internet user. It's this flood of data that is going to change the way the IoT gets architected and gets deployed. The graph on the left shows the global data sphere, which includes all data, so Twitter feeds, Netflix streaming, enterprise applications, and IoT today makes up a relatively small portion of the global data sphere. But in 2025, IoT data will make up almost half of the global data sphere. Further, it's predicted that almost half of that data will need to be stored, analyzed, and acted upon at the edge because it's either time sensitive or because of the way the architecture is set up, it would be simply too expensive to send that data to the cloud or to a remote data center. And I'm going to talk a little bit more about the edge, but this coming flood of data is another key element that's going to push and evolve the IoT. And that's why we're seeing an emergence for a greater amount of compute at the edge. You know, when I first used to give high-level pitches about the Internet of Things, I'd break it down in the simplest terms. You've got things, you've got a network, you've got a cloud or a data center. And those are the 3 key elements of the Internet of Things. But increasingly, because of a number of factors that I'll go through, we're seeing this new levels of edge compute required. And the reasons for that, I just showed you: the volume and cost of data transmission, the latency of sending that data all the way up to a remote cloud and back. A great example of that is obviously autonomous driving. You want to have low latency because sending that data to a cloud to tell you what your next direction could be dangerous. And that's sort of combined with the next one, which is lack of persistent connectivity. If the connection to that cloud or data center were to go down, what would happen to that Internet of Things system? And obviously, if it were to go down, you want systems that can still perform. And so edge compute located very close to the generation of that data is really important. Some kinds of data are just so sensitive that sending it outside of a premise is something that customers are uncomfortable with. And then the final 2 are around workload consolidation and analytics and AI. And workload consolidation is around taking multiple workloads and islands of technology that maybe existed before, disparate systems, and collapsing them down onto one system at the edge. And then from there, you can generate new insights because you've got systems that used to not even talk to each other now running within the same edge compute platform. And so analytics and AI become a very important part of the edge, which is why they're shown here. And so I wanted to take a break here and come back and show you. I talked about kits and the like. The edge compute is requiring a smaller form factor and tremendous amounts of computing packed into a small appliance-like box. And what I just held up was our edge compute reference design, which takes advantage of our power-efficient compute platforms, as well as accelerators like Altera FPGAs, and then applies them in a way that the edge can take advantage of and stem this coming flood of data. So as I wrap up, I want to leave you with a thought moving forward. At the beginning of the talk, we looked backwards 10 years, and we looked at the mobile ecosystem, the mobile developers, as a way of kind of thinking about what the future might hold for IoT. And I talked about these amazing use cases, about saving lives and helping first responders, about enabling remote healthcare, about improving agriculture, improving the lives of every people that live in cities through increased security and surveillance capabilities. And I showed you that video, what the future might look like. And I really think as we look forward, it's the innovation from millions of IoT developers, and we're on track to 10 million IoT developers that is going to build out this innovation. And of course, there are barriers and issues along the way, security and privacy, navigating the world of AI, around getting the right resources and hardening these platforms. But I think they're surmountable. I think they're surmountable due to the innovation of the folks that we have on the line today. And these millions of IoT developers are going to create tremendous impact. Economic impact is one way of measuring that. And McKinsey has forecasted that by 2025, there'll be over $4 trillion of economic impact created by the IoT. In fact, that's the low end of their range. The high end of their range in that study was $11 trillion per year. And so obviously we don't know what the future holds, but tremendous economic impact and tremendous human and social impact by enabling these use cases. And so I'm really excited about the innovation that 10 million future IoT developers like yourself could unleash using the Internet of Things. And I want to thank you for your time. And I now want to switch back to the video and answer your questions. One question is around some of the URLs for some of the products I talked about, like our Edge Compute Reference Design and the Enhanced Privacy ID and the Intel Secure Onboarding. So I will go to the conference site and I can publish some of the URLs for some of that. It looks like some people have published some of those already. There's a new question about what are some resources for hardware options for expansive edge arrays? And so hardware options at the edge. Well, the edge is a varied landscape, and so you've got things like gateways and Intel-based gateways. And so there are a whole host of ODMs and OEMs, companies like Dell, HP, Advantech, AD-Link, and a whole host of others that create a lot of different kinds of edge hardware. Some are ruggedized for certain applications like transportation. Others are in certain smaller form factors for other use cases. So the IoT Solutions Alliance, or the Intel IoT Solutions Alliance, is a great resource to go look. We actually have a solutions portfolio there where you can look at all the different kinds of hardware capabilities that are available to start developing on. And so that would be a good resource for people to take a look at. There's a question around, does EPID allow role-based security? Well, EPID stands for the Enhanced Privacy ID, and it is a group signing methodology which allows for a device to be known as a member of a particular group, be able to be identified exactly or precisely within that group. So that gives it a level of privacy. And so a layman's example of this would be if I owned a Ford automobile and EPID was loaded in that Ford automobile, a service might be able to attest that I own a genuine Ford automobile, but it wouldn't know that it was David Formisano's automobile because I'm a member of this group and there's more than one Ford automobile out there. And so I'll have to get back on exactly what is meant by role-based security, but yes, you can set up different kinds of groups and roles that allow the EPID key to behave in certain ways and be attested within a different kind of group signing methodology. And it's through that unique way of doing the attestation process that allows it to be secure all the way down to that immutable ID, but also retains some level of privacy. It's configurable. There's a question that says, so the Intel IoT platform is centered around an IoT. While gateways play an important role in IoT architectures, it's not necessarily around a gateway. I was highlighting that because there was questions about the edge. I guess I should have highlighted other types of edge devices. So we are embedding our silicon in other applications and hardware. So as an example, smart IP cameras, the cars themselves, we're working in embedding intelligence into automobiles. Health equipment, we recently launched a product called the Intel Health Application Platform for remote monitoring. And it is a small application platform at the edge that allows you to connect blood pressure cuffs and scale ability to look at your weight. And so while gateways is one part of our strategy, embedding intelligence into all the different kinds of things is also part of our strategy. Also working with our network team, because the network is really important in how we do connectivity. It's also very important to be able to connect into the data center. And so our view is looking across Intel, across the ecosystem, and connecting those. And so it goes well beyond a gateway. So there's a question around free and paid IDEs for IoT development. I'm new to the area and I don't know where to start. There are a lot of different capabilities that might be required depending on the use case that you're trying to embark on. And so obviously we offer a range of tools that range from sort of the prototype phase to production phase. I don't have at my fingertips all the differences between those and the pricing differences and capabilities. So that's something I think we'd have to follow up. I do know Gara has a topic all about our development environments tomorrow. And so if you can catch that one, that would be a great one to catch. And I'm seeing a question around plans to embed AI and machine learning instructions in chip, that there are coprocessors and accelerators. Are you planning to integrate those things? And so the answer is, I'm obviously not here to announce new products, but we already integrate certain capabilities. So as an example, we have integrated graphics, and graphics can be very useful in accelerating certain workloads in machine learning and deep learning. And as we look out in the future, we are looking at other ways to integrate key components for machine learning and deep learning. We've acquired companies to give us a range of assets in the space, companies like Movidius, companies like Nirvana. Movidius specializes in vision processing units, and so it's exciting to see all the different kinds of accelerators. I think we're going to see a world of integrated and non-integrated acceleration, and I think Intel will have a roadmap that encompasses both kinds. I appreciate everyone who was able to attend. Thanks again for your attention.